This question is from K 2020 Mechanical Engineering paper set 2, question number 43. A cylindrical bar with 200 millimeter diameter is being turned with a tool having geometry 0 degree, 9 degree, 7 degree, 8 degree, 15 degree, 30 degree, 0.05 inch. Coordinate system being ASA, resulting in a cutting force FC1. If the tool geometry is changed to 0 degree, 9 degree, 7 degree, 8 degree, 15 degree, 0 degree. So the last angle 30 degree has changed to 0 degree. 0.05 inches, which is again the same coordinate system. And all other parameters remain unchanged. The cutting force changes to FC2. The specific cutting energy in joule per millimeter cube is UC equal to U naught T1 raised to minus 0.4. where U naught is the specific energy coefficient and T1 is the uncut thickness in millimeters. The value of percentage change in cutting force FC2, that is FC1 minus FC2 by FC1 into 100 is dash. Let's find out. So the values of angles that are given, the last one which is actually changing is the side cutting edge angle. So we'll denote side cutting edge angle by CS. CS1 is given to be 30 degree and CS2 is given to be 0 degree. From here, we can find out the approach angles because in the formula for UC, which is the specific cutting energy, we have U naught into T1 raised to minus 0.4 and T1 is nothing but the uncut chip thickness. For orthogonal turning, T1 is written as F into sine lambda and lambda is nothing but the approach angle. F is the feed rate. So we need to find out approach angle using the side cutting edge angle. Approach angle is given as 90 minus the side cutting edge angle. So approach angle 1 will be 60 degree and approach angle 2 will be 90 minus 0, which is nothing but 90 degree. Now we'll have to find relationship between specific cutting energy and cutting force. We know that specific cutting energy UC can be written as power upon the material removal rate. This is by the definition of specific cutting energy. Power can be written as force into velocity. So cutting force into the cutting velocity V divided by material removal rate is nothing but volume removed of the material per unit time, which can also be written as chip thickness T1 into depth of cutting small d into the velocity of cutting. So chip thickness for the changed geometry, because we are calculating FC2, so it will be written as feed rate into the depth of cut into velocity of cutting. V by V can be written as 1. So by rearranging this, we have FC in terms of specific cutting energy. FC is equal to UC into F into D. Substituting the value of UC from here, we will have FC equal to U naught into T1 is nothing but F sine lambda. So F sine lambda to the power minus 0.4 into F into D. So all these values being constant, U naught, F and D, FC will be directly proportional to F into sine lambda raised to minus 0.4. Feed rate will also remain the same. So that can be also taken as a constant and therefore FC will be directly proportional to sine lambda to the power minus 0.4. For each of the FC1 and FC2, we can substitute the corresponding approach angles lambda 1 and lambda 2. Thereby, we can write the percentage change in the cutting force FC will be equal to FC2 minus FC1. So in place of FC2, we can write sine lambda 2 to the power minus 0.4 minus sine lambda 1 to the power minus 0.4 divided by sine lambda 1 to the power minus 0.4. Because FC1 is directly proportional to sine lambda 1 to the power minus 0.4 and similar is the case for FC2, just replacing lambda 1 with lambda 2 into 100 will give us the percentage change. So this, when we put the values of lambda 2 and lambda 1 here, sine 90 is 1. So this term simply becomes 1. We can separate out the denominator. So this term will be sine 90 to the power minus 0.4, which is 1, divided by sine 60 to the power minus 0.4 minus the second term will be 1 itself into 100. So we get the value of percentage change in the cutting force that is asked in the question will be minus 5.59%. You just have to put this in the digital calculator and you'll get your value. Let's go back and fill in this answer. So the value of percentage change in cutting force is minus 5.59. They haven't mentioned anything about the sign, so you can write the answer with the negative sign. To learn more about forces in machining, you can refer to the NPTEL video, Lecture 5, Forces in Machining. This lecture is from the course Introduction to Machining and Machining Fluids. The course is taught by Dr. Momilla Ravishankar. He's from Department of Mechanical Engineering of IIT Guwahati. I hope this helps you to solve your doubt. Thank you.